Hi, this is Mark. I'm going to do a little run through of the assignment instead of the labs we were supposed to do last week. The first thing we want you to do, so I added some information to the README. The only thing you're going to be doing for this assignment is one language, the parser, the evaluation function, and the monad plumbing, which you'll use to write the evaluation function. The first thing that we want you to do is go to the language definition, and you can see the abstract syntax tree of the language you have. This abstract syntax tree is hooked up to a show function, which does a lot of work to make the syntax look nice. So this is the definition of how this language will look when it's parsed. And you can play around and you can see how different things from the abstract syntax tree will look when in the finished language. For instance, I typed it. For instance, this will be what the user will type in, and this is the abstract syntax behind it. Hopefully you can play around and see what different things this little language has in it. It has bools and or not, it has integers, it has plus, minus, multiplication, division, it has an empty list, no way to build lists up, it has an if statement, it has a let statement, it has variables, it has lambdas, and it has application. And it's probably going to be helpful when you're debugging this to switch between the pretty printed version and the unpretty printed version. So now, if you're trying to debug something, you'll get back the easier to read version. And you can switch back and forth. So the point of this language is to compile down to values. Our values are integers, booleans, lists of values, or functions over values. We need to have functions over values because this is a functional language. We'll get back to this in a second. Here you'll be writing the eval function. Let's just start that out. So if we have, for instance, a plus, LR, well, we would want to use do notation, and then we could say, well, whatever the eval of the left is, let's call it a result, and the evaluation of the right branch well, that should result in an integer value. That simply adds them together. So I think this works, but the problem is these are just any val, as you could read on the type signature. And we only want them to work for integers. So we could do a bunch of case statements here, and that would be fine. Or if you're trying to be a little bit better, we can write an eval int helper function, which just calls a val. And we'll then just check if the result is an int. If it's an int, we're good. We'll just return the int. Otherwise, we'll say an error. And we can return an error using the helper functions in the monad class we're going to define. So, oh, wrong monad. Yeah, right here. So, we have an error function that will nicely report an error. And this just gives us an easy way to avoid having to write out a bunch of case statements every time. Oh, what did I get wrong? Oh, of course, I need to return it. There we go. So, obviously, let's add a little bit here so that we can test it out a little. Val int, well, that's an easy one. Val int, we're just going to return R. I'm going to mess it now. Oh, of course, need to wrap it. So now it would be nice to test this, and we could write a little test function. Eval plus 2. And we're going to have a problem because we haven't defined this monad, so this do notation isn't hooked up to anything yet. So let's look at the monad we have to build. We're working in a pure functional language that can have errors. So the first thing we're going to do, the first thing we did is we have this data that captures either a string error or or the correct value. And then we're also keeping track of an environment that we can then look stuff up into. So what you'll have to do is you'll have to fill out the functor definition, and it's kind of the only obvious thing if you follow the types. You'll have to fill out the return and the bind definitions as well, and again, it's kind of the only obvious thing if you follow the types. So there are some unobvious things that you could do. For instance, so let's just follow the types and do something bad. So if this is an unsafe environment, well, the only way to create an unsafe environment is to use the constructor. So let's use the constructor. Okay, and that takes in a function, so let's start a function, and let's just be silly and always return an error. So this will actually type check, but this doesn't actually follow the functor laws. It specifically doesn't follow the functor law where if we apply identity, we're always supposed to get the exact same thing back. So if if you can think about it, this is kind of another. So when we talked about the laws, they're encoding the common sense we tell you to use, and that you've probably been using all along. And that's a good thing to think about while you're working on this. Let's see. There's a few helper functions. This one will just get you access to the function. You can always use the constructor to build things up. There's an error function. If you ever want to get the environment, this is a nice way to pull in the environment using do notation. So we can just use, you can write something like do and then you've got the environment to use with whatever you want to do later. So there is, let's see, there's one last bit of, yeah, so most of this will be easy to implement except the lambda bit. For the lambda bit, you'll have to write a closure. And I'm forcing you to write a closure such that the entire thing is captured within a function. So if we have lambda, it has a variable and a body. And what you're going to want to do is well, we're going to need the environment because we're going to need to capture the environment. And then we need to return a function. Again, if you follow the types, there's not a lot of choices you have here. So the only way to make a function is this. And the function is going to take in some value. And the way we're going to run this function is we're going to basically call eval on the body. This is where we need our helper function here. We're going to call eval using a very specific body. Using its very specific environment. And that environment is going to be the one that we picked up when we're creating the function. This way, if we have something like let x equals 3 in lambda y plus x, and then we use this function sometime later, and then in that environment x gets set to 7, this x is still linked to the correct 3. So we'll do this eval, we'll do it on the body, and we'll run it with the old environment we captured. Well, that's not exactly right. We want to insert the value for x in our old environment. And does the types line up? Let's see, insert. I'm forgetting how to use insert, ty. Oh, xv, that's what it is. There we go, and this should be right. You could also use do notation inserted below. That should get you an idea. There are some other helper functions that you might find helpful. Of course, you never have to use them if you don't want to. If you want to hint for value of, just look at last time, or a time, yeah, I think it was last time, we defined something very similar to this. And again, if you follow the types, it's a little hard to mess up. Yeah, and if you want an extra challenge, I think you could write this series of functions with a helper type class, which would be kind of cool. But if you don't want a challenge, don't worry about that. Finally, we're going to have a couple standard library functions, and I've started one out for you here. This one just gets the tail, so when we call the function tail is already defined for us. So that's all you need to do for the evaluation function. Yeah, once you have this monad, this should be hopefully straightforward. Now, the part that's going to be a little bit more difficult is the parser. So this language has a lot more stuff going on, and we're trying to be a little bit realistic, so we're using the, we're using the C rules. Lots of programming languages use the C rules, but people have kind of realized that there were perhaps some mistakes that were made that lots of languages have inherited, and that's okay too. We're just using it as a way to just have some kind of sense. So we've got a lot of symbols that are going to be in our language, and they all have a precedence order, and you should have gone over that in lecture. So remember last time we implemented this multiplication, division, plus and minus, and it was like a lot of work because we had to build up these left associative things, and it took several steps each time. This time I'm giving you a helper function that just generalizes what we did before. So this helper function will take a string that we expect to pepper throughout a parser, and a way to combine the left and the right size, and it will accumulate it'll accumulate those things according to our function in a left associative way. So I have some example. There's a cute little example right here that does infix addition and subtraction. So it takes the standard int parser. When it sees a plus, it actually does the plus operation. When it sees the minus, it does the minus. And it'll just build these up in a left associative way. So this actually copies most of the work we had from last time. And then I've listed these things basically in order. So in order of precedence. So as you do one thing, you can feed it into the next level of precedence. So for instance, not the exclamation mark, which is not, binds more tightly than multiplication or division, according to C. So we can take that and we can say with infix this, and we just need to give it a way to handle our multiplication and division. Well, we want multiplication to be linked to, well, we need a function that handles multiplication for our language. Well, guess what? Constructors are basically functions, so there we go. And wrong slash, yeah, there we go. And what's that? Division. Yeah. Yeah, and you can just keep doing that. And again, play around with everything. So let's say we don't know how to parse not yet. Just fill it in with something to start out with. I think I give you I gave you a little variable. You don't have to actually exclude these keywords, but it makes it a little bit more sane if you do. So we can do this, and now we can, as always, test everything as you go. parse this thing, and we'll want to parse it on, say, x times, x times y divided by z. Yeah, and it's actually a little hard to see that worked out correctly, so let's go back to our language, and as I was saying before, we can turn off the pretty show. Now we get the gory details, and if I didn't make a mistake, yeah, you'll see it left associated correctly. So hopefully this is a lot easier than it looks. It's a bit of work. It's going to be very hard to do unless you test pretty much every step. I'll post a couple more tests, but you'll need to do a lot of testing on your own. Hopefully that's okay. Please post any questions you have on Piazza. Yeah, and hopefully this is easy and you have a nice Thanksgiving break.